Hello everyone. In this video, we shall see how to write a Python code to find inverse of a matrix using adjoint method. So in the previous videos, we have already discussed determinant of a matrix. So as you can see on the screen, this is what I discussed in the last video. So to find the inverse, we are going to use this determinant definition which we have already defined, and we shall add the extra stuff required here. Now, before getting into the inverse, uh, what is inverse of a matrix? Using adjoint, A inverse is nothing but 1 upon determinant of A into adjoint of A. So if I want to get the inverse, two things I need. One is the determinant. So I already have this ready. Now I have to write Python code to get adjoint of the matrix, right? So if I take, let's say, a 3 by 3 matrix, A00, A01, A02, A10, A11, A12, A21, A20, A21, A22. Then how do you go about to find the adjoint of this matrix? So first what you'll have to do is you have to find the corresponding minors and get their determinant. So I'll find the minors corresponding to M00, M01 and determinant M02. These minors I'll need M10, M11, M12 and M20, M21, M22. So once you get the minors, you are going to implement these signs there. So I am going to multiply these entries by negative signs. These four entries, right? As per this pattern. And then I have to take the transpose of this to give you the adjoint. That will give you the adjoint of the given matrix A. So if this is A, then adjoint of A would be this. So firstly, what I'll have to do is I have to find the minors. To those minors, to these terms, these four terms, I have to multiply the negative sign. And then I have to take the transpose as well. So these three things I need to do. Okay. And once we are done with that, 1 upon determinant A, we are going to multiply to this matrix, and that will give us inverse of the required matrix. So this is the logic behind writing the Python code to get the inverse. Now what we will do is we shall define a function to find adjoint of a matrix. Okay. So now I hope you are comfortable in defining functions. It's already discussed in the earlier videos. So I'll define adjoint, let's say of a matrix A. I need a function to define to get adjoint of the matrix A. Okay. So adjoint of A I need. Yeah. So I'll need again two variables to run over the rows and columns of the matrix A. So let me define two variables, M to be length of A. Okay, M will be length of A. And another variable, let's say as usual, what we take, I'll take N to be length of A0. Length of A0 that will run over the columns of the matrix A. Okay. And I'll ask Python to return Now, if you remember, we wanted minus signs only at the alternate positions, right? So I don't want to multiply that negative 1 to all the entries there. Only the negative, only the alternate entries, we need those. So that can be done by taking powers of minus 1 with respect to the position. Okay. So this will be, firstly, I'll have to take minus 1 raised to I plus j, because that will I'll have to multiply to all the entries. So minus 1 raised to I plus j, and how do I take the power? I'll have to put two star signs, right? Minus y raised to I plus j, that will be the position of all the entries. So when I plus j is even, it won't multiply a negative sign because it will be 1 there, right? So again, I'll close this in a round bracket so that this becomes one term. Yeah, so this is minus 1 raised to I plus j. So this basically I need to take, and I'll have to multiply it to the determinant of the minors. So this times determinant of, determinant function is already defined above. Determinant of minor function is already defined. Minors of aij, aij. Determinant of minor of aij. Now I have to say from where I and j are coming. For j in the range of n, again for loop being used here. For j in the range of n, that will give me the row wise entries. And to get into the columns, I will go ahead. I can remove this extra spacing. For I in the range of n. For I in range of n. Okay, maybe I'll get it down. Yeah. So what this will do is it will compute the determinant of the minors, and to the alternate terms, it is going to multiply a negative 1. Right? So that will give me the adjoint of the given matrix. Now, once I have the adjoint, I'm ready now to define the function for inverse. So let's say inverse, I'll give the name INV inverse. And my arguments will be, I'm finding inverse of the matrix. So one matrix I'll have to give inside. Let's call it A. So define inverse of A to be. Again, I'll need two things there. One variable to run over the rows, one variable to run over the columns. So I can just copy and paste these two here. Yeah. Now, 1 upon determinant of A, what I'll do is I'll give one variable to it. Any variable that's just a dummy variable you can give. Let's call it R. So I'll call R to be 1 upon determinant of A. But since I'm dividing, it could be in decimals also. So I'll have to use float there because it may not be an integer. Okay, so float of 1 over determinant of A. So 1 divided by determinant of A. So my determinant function is det we had used. So determinant of A I'll have from here. So 1 upon determinant of A is nothing but R. Okay. And now I'm ready to ask Python to give me the final definition for inverse. So that will be, I'll ask Python to return again. I'll be using list as comprehensions itself. There are various ways of getting this. So this is one way. 1 upon determinant of A. So for me that is R into adjoint of A. So I have to multiply this basically to all the entries of the matrix of the adjoint of the matrix A. So R, that is 1 upon determinant of A into adjoint of A, all the entries, right? So I'll have adjoint of A here. Adjoint of A, adjoint of A, all its entries. So I'll have to, in square brackets, put the position ijth entries of the adjoint, right? So 1 upon determinant of A into adjoint ij. So basically that will count each and every entry for j in the range of n. Oh, one thing I forgot to do, which I will tell you in a while. For j in range of n, for j in the range of n, okay, now I'll move to the other list, and for I in a range of m. Yeah, right. So this will multiply 1 upon determinant of A to each and every entry of the adjoint matrix. But one thing that I missed was I forgot to take the transpose of the adjoint. So right now in the adjoint definition, what we have is the cofactors, right? So there are two ways now. Either you can define another definition to get the transpose the way we had done earlier, and then of the adjoint you can take the transpose. Or in this definition here, minor of Aij, I can directly swap it with Aji. So transpose I'll be directly getting from here by swapping ing. So that will give me the transpose. Otherwise, if you wish to, you can define another function, as I said earlier, and you can get the transpose, and that you can call it as the adjoint. Okay. So I'm not defining any different function. Aij, I'm changing with Aji there. So that will take care of the transpose because you're just swapping the row and the column position. Okay. So I have defined the inverse function now. So now I'm ready to print inverse of E. So I'll say print inverse of E. Okay, if you wish to, you can print adjoint as well. And I've printed the determinant. So I'll get the determinant of the matrix and the inverse as well of the matrix. And the matrix that I've taken is 1, 2, 3, 4, 2 by 2 matrix. This will work for any square matrix actually. Okay, so let's see if there are any errors. I'll run this, save it. Oh, so there's some error there, indentation error. Let's figure out what is the error. I've got some indentation error here. Okay, give me a minute. Let me rectify this. I'll run this once again just to check where the error was. Unexpected indent. So some extra indentation I've put somewhere. Okay, give me 1 minute. I'll just try to rectify this. Or it might be in the adjoint. No, this is fine. Adjoint looks fine. Let me look at the inverse. Oh, here by mistake I've put I think underscroll there. Yeah, yeah. There was an underscroll there by mistake. I think it appeared. Yeah, so that is rectified. So I'll run this, and that will give me the determinant is -2 and inverse is -2, 1, 1.5 and minus 0.5. So that is the required inverse. You can also get it in the matrix rectangular form. Okay. It's already discussed in the earlier videos. So if you wish to do that, you can do that as well. So this is how you write a Python code to find inverse of the matrix. Now, another way to, instead of defining the inverse as a function, you can probably use scalar multiplication function as well. So instead of defining this inverse as a function, you copy and paste the scalar multiplication program that we have already discussed earlier. In this playlist only you will find it. And the scalar you can take it as 1 upon determinant of A, and the matrix you will be taking is the adjoint of the matrix. Okay, so that will be again you'll have to define the function for scalar multiplication there as well. So that will be little time saving. So you can try that and let me know whether that works or no. All right. Okay, so that's it for this session. Thank you.